All right, this will serve as the final tutorial for the first unit of pre-calculus. So this is evaluating, not only evaluating trig functions, but the inverse trig function. So this is clearly not a trig function on the board, but we're going to talk about inverses, not graphically. We'll talk about them graphically in the next unit, but we'll talk about trig functions, how they relate inputs and outputs. What does that mean in terms of, um, the inverse of a trig function? So here's a regular function. If I wanted to look at an input-output table, all right, I could do x and f of x, but if I look at x and y, right, 0, 1, 2, -1, -2. If I plug in 0, I get out 4. Plug in 1, I get 2 plus 4 is 6. Plug in 2, 2 times 2 is 4. 4 plus 4 is 8. All right, I can see that's going up by 2. It's a slope of 2. All right, 2 and 0. So it's a nice, easy linear function. All right, what an inverse function does, all right, so the inverse of that would give me the same table except for it switches your domain and range. So it's switching your x and y. So essentially those inputs would actually be, when I have an input of 8, I get an output of 2. If I have an input of 6, I get an output of 1. If I have an input of 4, I get an output of 0. If I have an input of 2, I get an output of -1. If I have an input of -2, I get an output of 0. All right, and the easiest trick to find an inverse function would be to switch x and y and then solve. So I would have x equals 2y plus 4. Take away 4 on both sides. So x take away 4 is equal to 2y. Then I would divide by 2. So x over 2, so y is equal to x over 2 minus 2. All right, and that's what would be producing this table over here. All right, it's an inverse function because it's switching the domain and range. Oops, forgot to write y. All right, switches domain and range. So the inputs of one function is the range of the others. All right. So if we're thinking in terms of trig functions, all right, if I have the sine of pi over 6, well, that is equal to 1/2. So if I had the inverse sign, which could be right with the -1 symbol, which I'm not a big fan of because that makes you think of 1 over sine, which is actually cosecant, but inverse sine is a different thing than cosecant. If I have the inverse sine of 1/2, my output is pi over 6. Now, here's an interesting problem is, well, what if I have the sine of 5 pi over 6, whose reference angle is also pi over 6, so the sine of pi over 6 is 1/2. Well, if I do the inverse sine of 1/2, I'm still going to get pi over 6, right? And it's similar to when you're working with quadratics, all right? So, all right, if I think of x squared, well, the inverse of that is the root x. So I can go, well, all right, if I have x, when I plug in 1, I get 1 squared is 1, and the square root of 1 is 1. Plug in 2, 2 squared is 4, and the square root of 4 is 2, right? If I plug in -2, well, -2 squared is 4, and the square root of 4 is 2. Right? There's an issue with the range, right? Its outputs are limited to positive numbers when you're square rooting, right? But when you square it, you square negative, so you can have two different inputs that output, but it's a restricted range, which we'll look at when we look at it graphically. But essentially, it has to only have one output. In order to be a function, it has to have one output when I'm putting in 1/2, right? So question is how do they limit it? So I have a small sketch of a unit circle on the right. Well, we know they're all positive here. So all of these can be a part of the domain. But in terms of getting negative values, right? So we're not even worried just about coterminal, but negative, right? That's the other thing I look at, sine of negative pi over 6, right? Sine and tangent are negative here, and cosine is negative here. So they're going to have different ranges. All right, so let's take a look real quick, and we'll see why that is. All right, so let's look at negative pi over 3. All right, well, the cosine of negative pi over 3. Now remember, negative is going the opposite direction, so that's going to be a fourth quadrant angle. Negative pi over 3 is about here. Right? Cosine of negative pi over 3 is a positive number. Right? It equals a positive 1/2. So if I do the inverse of 1/2, I'm actually going to get a positive pi over 3. All right, let's look at it for sine and tangent. All the sine of negative pi over 3 is equal to negative root 3 over 2, right? It's negative down there. And if I do the inverse sine of negative pi over 3, oops, excuse me, negative root 3 over 2, I will get out an output of negative pi over 3. All right, and they want a continuous range. Similarly, tangent will follow suit with sine. So the tangent of negative pi over 3 is equal to a negative. All right, so it's sine divided by cosine, which we already have up here. So root 3 over 2 divided by half, so it'd be negative root 3. Hopefully I didn't mess that up. Tangent's one of those ones I don't have memorized, but sine over cosine, it should be root 3. All right, and then if I do the inverse of negative root 3, I should get out negative pi over 3. All right. So you can see it's a little bit interesting when we're looking at negatives. All right, but I didn't put a negative into the inverse of cosine. All right, so both of those are together. So sine and tangent behave similarly, cosine behaves differently. All right, so the third quadrant's kind of ignored, so I'm going to look at a third quadrant angle, and we'll look at it for sine, cosine, and tangent. All right, so let's say, I don't know, this could be 5 pi over 4, or some coterminal angle with that. So if I have the cosine of 5 pi over 4, that is equal to negative root 2 over 2. Now the inverse cosine of that, negative root 2 over 2, is equal to 3 pi over 4. All right, basically it's the smallest angle that also has a cosine negative root 2 over 2, right? It's that second quadrant angle, right? It's the reference angle in the second quadrant. All right, well, what about tangent and sine? So if I do the sine of 5 pi over 4, well, that's also negative. The sine of 5 pi over 4 is equal to negative root 2 over 2 as well. However, the inverse sine is going to be in a different quadrant. All right, it's going to be this angle over here, which they're not even going to call 7 pi over 4, negative pi over 4. Again, they want a continuous range, so I'll tell you what I mean by that in a second. So negative pi over 4. And then I have tangent 5 pi over 4, which is 1. The inverse tangent of that, oops, 1, is not 5 pi over 4. It's going to be in the first quadrant. So it's going to be pi over 4. Very interesting. All right, so there's different range for each of these functions, and obviously they're positive and negative in different quadrants, so that's why they're coming out different ways. But essentially it's limited because why isn't it coming out 5 pi over 4? Why isn't this coming out 5 pi over 4? Why is this not coming out 5 pi over 4? Why is this not coming out 5 pi over 4? All right, and that's because 5 pi over 4 is not in the range of any of these inverses. All right, so what are the ranges? All right, they want a continuous one. Now they all are positive in the first quadrant, so they all want the first quadrant to be a part of it. So cosine wants this to be a part of it. right? That, and they all like it. So cosine wants to be a part of it. Sine wants a part of that. And tangent wants a part of it as well. All right, so cosine is negative in the next quadrant, so the next quadrant that cosine is negative in is the second quadrant. All right, but sine and tangent are right, so sine and tangent aren't negative, so they will. All right, sine will have to go this way. Now, interesting. So sine is not negative in the second quadrant, but tangent is. Tangent could go left or it could go right. But we actually prefer tangent to be in the fourth quadrant, because then it's going to be easier when you're doing inverses, because anytime it's negative, it's just the negative angle. And we'll see what I mean by that. All right, so if I think in terms of radians or degrees, so for the inverse cosine, which is also called the arc cosine, so the reason they do that is they don't want you to be confused with that -1. You don't want you to think that arc cosine is the same thing as secant. All right, but if we're looking at the range, it's going to be between 0 and pi, right? That's the first and second quadrant angle, or 0 and 180 degrees, right? Any calculator would abide by this. All right, so arc sine, or the inverse sine, that's just another name, would be between pi over 2 is the top of the first quadrant. That's going to be your cap, and then negative pi over 2 would be the bottom of the fourth quadrant. So that's going to be between -90 and +90, which makes for a nice easy range. Whereas cosine's kind of the odd one out. It's awkward because it doesn't have a negative. Even when you're taking inverse cosine of a negative number, it's always going to be positive. All right, and tangent, or the inverse tangent, or arctangent, have the same range as sine. And that's just for convenience, because for tangent we can actually pick, whereas cosine we're forced to use the second quadrant. All right, they also have to stop it because, all right, let's just take, for example, the inverse tangent of -1. All right, so if I think of everything that has a tangent of -1, well, 3 pi over 4 has it. So does 7 pi over 4. So does 11 pi over 4. So does negative pi over 4. Right, there's an infinite amount of things that have that. So in order to be a function, we have to limit it. Well, instead of going, it would seem awkward to be going from, pi over 2 to 0 and then calling this 0 to 3 pi over 2. It would be a union, right? That would be saying, oh, we're from 0 to pi over 2 unioned with 3 pi over 2 to 2 pi, right? That's a really awkward range, which is why they wanted it to be continuous like that. And we didn't want that as a range. All right, so those are the possible outputs. If we're inverse tangent -1, it would be negative pi over 4. That's the only one that's in that range that has a tangent of -1. All right, so these ranges are important. Let's see if I can move this up. Just for to go together. All right, those are the possible outputs. And again, it has to do with it being a unit circle, wanting a continuous range. And then for tangent, we chose to have a negative part of the range because I could go positive, or I could go to the second quadrant or the fourth quadrant, and it's convenient to be in the fourth quadrant. All right, because quick example, inverse cosine of negative pi over 6. For us, we have to think, oh, the reference angle is 5 pi over 6, and oh my god, excuse me, negative root 3 over 2. All right, it wouldn't actually be, it would be in the second quadrant, or it would be this angle here. Whereas if I was looking at the inverse sine of negative 1/2, all right, well, the sine of 1/2 is usually pi over 6, so I can just really easily go, oh, it's negative pi over 6. All right, it's this one right here. All right, I didn't have to find that reference angle, right? And this is a little bit awkward because you have to think of the reference angle in the second quadrant. All right, same thing with tangent though. If I'm doing tangent of negative root 3, all right, I can just easily go negative pi over 3. All right, I could look off the chart and just make it negative, whereas for cosine, I have to look at the chart and find the reference angle that's in the second quadrant. All right, we'll practice that on the next tutorial.